Let's talk about x and y intercepts of a graph. So here we have a random graph of a curve, and we're going to label the x and y intercepts of the following graph. So let's first talk about what x and y intercepts are. X-intercepts are where the graph crosses the x-axis. So where a graph crosses the x-axis. And hopefully remember the x-axis is the horizontal one. Y-intercepts are where a graph crosses the y-axis. So where a graph crosses the y-axis. This one says label the x and y intercepts on this graph. The grid didn't come out really well on my printer, but it looks like this first x-intercept, because it goes through the x-axis, is the point -4, 0. So one important thing that I need us to remember are that intercepts are points. They are not just numbers, they are points. So we should have both an x-coordinate and a y-coordinate when we're labeling an intercept. The next x-intercept here, if we look at this grid, it looks like that's 2, 0. And then this final one crosses through 5, 0. So this graph has 3 x-intercepts because it crosses the x-axis 3 times. So let's look for the y-intercepts. The y is our vertical axis. And functions will only cross through the y-axis once. So there should only be one y-intercept. And this one occurs at the point 0, 3. So let's look at what these have in common, because they are all points, but one thing that they all have is one of the coordinates is a 0. So to find an x-intercept, these x-intercepts here all have a y value of 0. So x-intercepts always have a y = 0, and then it's x that's going to be different. So then we would solve for x to find those x-intercepts. A y-intercept, if it crosses through the y-axis, then it has to have an x value of 0. So to find a y-intercept, we let x = 0 and solve for y. So this enables us to find intercepts without a graph. So let's do an example of that, and then there'll be a couple other examples that we'll do in subsequent videos. But let's try this one. It says find the x and y intercepts. So if I want to find the x-intercept, we're going to let y = 0. And we're just plugging that in. So where there's a y, I'm going to put a 0. So that'd be 5x minus 2 times 0 = 20. Plugging in 0, what that does is it makes this term 0. So we'll just get 5x = 20. And then if we divide both sides by 5, that makes x = 4. So our answer isn't just x = 4. The answer is the point where y = 0 and x = 4. So the x-intercept is the point 4, 0. So let's do the same thing for finding the y-intercept. To find the y-intercept, we're going to plug in x = 0. So same starting equation. It's a line in standard form. So it'd be 5 times 0 minus 2y = 20. So again, by plugging in 0, this term is going to be 0 or go away, or not affect the equation. But we can't forget this negative sign here. So this started out as subtraction, but subtracting 2 is the same as adding a -2. So it needs to be a -2y = 20. So then when we're dividing both sides, we need to divide by -2. So that makes y = -10. And again, a y-intercept is not just this number, it's a point. So we found an x that goes with this y, so our intercept is the point 0, comma, negative 10.